Hi everyone, welcome to our final team teach. My name is Claudia.
I'm Jasmine Rodriguez.
I'm Jessica Johnson.
I'm Cytlaly Rodriguez.
Right, let's get started. Jessica, can you explain to me how you made this chart?
Claudia, I would love to explain to you how I made this chart. I used a range of -2 to +2 for my variable x.
If I remember correctly, the variable has to follow the rules that a function gives them.
You're right, CC. Our given variable in the x column has to follow the rules that the functions of y equals x squared, y equals x squared plus 7, and y equals x squared minus 7. Let me work out one for you to show you how I use the variable and the functions to graph my chart. Take y equals x squared, fill in the missing information to make it look like y equals -2 squared. When we solve, we get y equals 4. This information gives you a coordinate that can be graphed.
Ooh, can I guess the coordinate?
Yes, Jasmine, go ahead.
I think the coordinate will be -2 for x and 4 for y.
Yes, Jasmine, you are correct. You use our chart to figure out the xy coordinate of -2, 4. Going back to our chart, this is where the coordinate -2, 4 is located. And as you can see that a parabola was formed. A parabola is a curved line that has equal distance from fixed points.
Jasmine, can you show me the difference between a rotation and a reflection rigid motion?
Yes, Claudia, I would love to. First, let's look at the rotation. We will begin with our image on the left, and to create a rotation, we will hold the image in the center and turn it clockwise 180 degrees. Our rotation will look like this. Now let's look at a reflection. Let's create a reflection over a horizontal line through the center of our square. This will invert our trapezoid, and our square will look the same. The triangles will also be flipped, and this is how our reflection will look like when we're done.
Claudia, how would you find the perpendicular line found through the equation?
Excellent question, Jessica. First, we must locate the slope of the line, which is directly in front of the x in the equation. The slope, therefore, is -3/4. When finding the perpendicular line, the slope is the negative reciprocal of the original slope.
But isn't the slope already negative?
Yes, CC, it is. Since the original slope is already negative, then the negative reciprocal would be +4/3. Next, we plug the numbers into this equation here. Like that. Plug into this equation here, and the given point is plugged in for y1 and x1, as so. Then we solve by simplifying the left side and applying the distributive property to the right side like so, and finally we solve for y to write it in slope-intercept form, and the final equation is the perpendicular line.
CC, can you explain to me what is the correct name for the following triangle?
Of course, Jessica. This shape is called a tetrahedron. It is a polygon that has 4 plane triangular faces. It also has 4 vertex corners inside of them. It also has 6 straight edges. This is an example of a pyramid. Which can help you remember what a tetrahedron is.
Thank you, CC.
Jasmine, how do we determine that this is an undefined slope?
CC, there are a couple of ways that you can tell. The first way is through our given points. If we look, we have point R at 5,8 and point S at 5, -8. And we see that our x value is the same for both points. And this means that when we plot our points, we will also get a vertical line. And whenever we do that, that means that it's going to run up and down our axis, and we know that vertical lines are undefined. The other way to tell that our slope is going to be undefined is by finding the slope through our slope formula. When we solve for our slope, we have our denominator as 0. Anytime that we have a 0 in the denominator, our slope will also be undefined. Jessica, how do I find the area and the perimeter of this triangle?
To find the area of this triangle, we use the formula A equals 1/2 times B times height, with the altitude of the triangle being the height. Fill in our formula and we get A equals 1/2 times 82.3 times 41.0, making the area equal to 1,687.15 meters squared. Now, define the perimeter. Does anyone remember how to find the perimeter?
Oh, I do. I remember you add the numbers on the outside edges of the triangle.
Yes, Cece. To find the perimeter, we add the value of the outer edges together. Take 48.0 plus 69.0 plus 82.3 equals 199.3 meters.
Claudia, there are so many unknown angles. How do you even begin?
That's a great question, Jasmine. A problem like this can be very overwhelming without a little basic knowledge of triangles. First thing you can do in a problem such as this is to complete the main triangle. Like a straight line, a triangle equals 180 degrees. In other words, the three angles of the triangle add up to equal 180 every time. Knowing this makes filling in the first unknown angle really simple. Take the two main angles, add them together, and then subtract the number from 180, and you have the first angle.
Jasmine, how can we determine if this graph represents a function?
Jessica, let me tell you, we can check by performing a vertical line test. This is done by checking the graph to see if any vertical line that we draw would intersect the curve more than once. Let's begin with our first vertical line. Cece, does it look like it crosses the curve more than once?
No, it only crosses at one spot.
Excellent, Cece. Let's try a few more vertical lines. As we can see, none of these lines cross our curve more than once. Therefore, the graph does represent a function.
Jasmine, could you show me a graph that does not represent a function?
Yes, Claudia, let's take a look. Let's look at this graph, for example. Claudia, do you think that this graph represents a function?
I don't think so. It looks like the line will touch the curve more than once.
Well, let's find out and let's perform the vertical line test. The first line looks good. Let's look at the second line. That also looks like it only touches once. Okay, well, this line looks like it crosses at 3 different places. This means that this graph does not represent a function. You were right, Claudia.
Jessica, can you explain how to find the measurement of interior angles?
Great question, Cece. First, count how many interior angles that you have. Cece, I have colored each interior angle. I use different colors so you would not lose your place.
We have 9 interior angles, correct?
Yes, the polygon is called a nonagon. We will use the formula of n minus 2 times 180 divided by n. N represents the interior angles. When we fill in the missing information, we get the equation of 9 minus 2 times 180 divided by 9. After we solve, we learn that the interior angles of a nonagon has a measurement of 140 degrees.
Cece, can you tell me how a cylinder, a sphere, and a cone is considered a 1 to 2 to 3 ratio?
Excellent question, Claudia. Let's figure out the volume of all 3 shapes first. The volume of a cone, we will use the formula of 1/3 times pi r squared times 2r, giving us 2/3 pi r cubed. Then we have to find the volume of a sphere, being pi r squared times 2r equals 2 pi r cubed, equaling a total of 6/3 pi r cubed with a total of 2 pi r cubed. Finally, we have to find the volume of a cylinder, which is 4/3 pi r cubed. Let's say we have the cone to fill it up, and it will take 1 cone to fill up just the cone. It will take 2 cones to fill up the sphere, and it will take 3 cones to fill up the cylinder. This is how we know it's a 1 to 2 to 3 ratio for the given shapes.
Gotcha.
Jasmine, what is the difference between a concave and a convex polygon?
Jessica, I know these two can get confusing, so let me explain. Let me first tell you what a polygon is, and that is a shape that is formed while connecting a series of line segments like we have done here. So for a polygon to be convex, we can choose any 2 points on our polygon, and you go ahead and plot them, and when you connect them with a line segment, that line will never exit our shape. On the contrary, on a concave polygon, we also go ahead and choose 2 points to plot, and when we connect those, our line will also exit the shape, as you can see right here.
Yes, thank you for clearing that up for me.
Jessica, how do I know if this is a vertex figure or not?
Claudia, I'm glad you asked that question. It's a good thing we learned about interior angles earlier because we need to know where these are to figure out if there's a vertex angle or not. These three angles must add up to equal 360 degrees. The interior angle of an octagon is 135 degrees. The interior angle of a hexagon is 120 degrees. The interior angle of a pentagon is 108 degrees. When we sum all the interior angles together, we get 363 degrees, which does not equal 360 degrees. Therefore, it is not a vertex figure.
Gotcha.
Cece, can you tell me the name of this shape?
Well, of course, Jasmine. This shape is called a right triangular prism. To find the surface area of this triangular prism, we have to do step by step to follow the steps. The first step, we have to use base area formula, 1/2 times base times height, where our base is 15 and our height is 8, giving us a total base area of 60 meters squared. Next, we identify the perimeter by adding up all the sides, 8 plus 15 plus 17, giving us 40 meters. Finally, to solve the surface area, we have to plug in for the formula 2b plus ph. So 2 times 60 plus 40 times 7 gives us 400 meters squared.
So this question asks that we find the answers to a series of equations once set variables have been plugged in.
What is a variable?
Great question, Jessica. A variable is a piece of an equation that may change or that has yet to be solved. In this function, the variable is the letter x.
Wait, what is a function and how is it related to variables?
Also a great question. A function is just an equation or relationship that uses at least one variable. Within a function, each input, or the x, only produces one output, which would be the answer. These outputs become the y values and the inputs are the x value when graphing. Once we know all of these values, we can take the x and y points and each function becomes a line on a graph.
Jessica, can you explain to me how to find supplementary angles in the figure?
Yes, I can. Since we already know that supplementary angles are when two angles are added together to get 180 degrees. I went ahead and figured the measure of the angles for you. In order to have a supplementary angle, two angles must share a side and form a straight angle. Let's look at this section in the box right here to explain what supplementary angles are. These two measurements share the same side along a straight line, and they are adjacent from each other. Try summing 119 and 61 together and you get 180 degrees. This theory applies here, and here, and here.
Cece, can you explain to me if angle QPT is equal to angle SPT?
Of course, Claudia. It is a fact. In fact, it is true because they have the same corresponding angles and congruent triangles. Corresponding angles are angles that occupy the same relative position of each intersect where a straight line crosses two others. Congruent Congruent angles have the same angles in degrees or radians. This means since the sides of the triangles are congruent, meaning all the sides are the same, and corresponding, meaning two lines intersecting in the straight line, this is why angle QPT is equal to angle SPT. Let me show you how both the green and pink triangles fit in for the triangles perfectly, QPT and SPT.
Loading.
As one can see, both triangles fit perfectly in the spots that were put in, meaning they share the same angles and are congruent to one another.
Awesome. Technical difficulties, hold on. All right, Jasmine, can you explain the difference between volume and surface area?
Yes, Claudia, this is one of my favorite questions. Let's begin with surface area. Surface area is the amount of space that covers the outside of a three-dimensional shape. In order to calculate the surface area, we add up all the areas of all the faces of the shape. Surface area is measured in square units. Think of a can of soup. The surface area is the amount of aluminum that it takes to actually make the can. Now let's think about volume. Volume refers to the amount of space inside of the 3D shape. Let's think about our can of soup as well. That would be how much soup, for example, would actually go in our can of soup. The volume would be the amount of soup that it holds.
Okay, that makes sense.
Claudia, how many mouthfuls fit into a cup?
Very fun question, Jessica. A cup is made of 2 gills, as you can see here. So the question is, how many mouthfuls are in a gill? And then we'll just double it. A gill consists of 2 jacks, and each jack consists of 2 jiggers here, and each jigger consists of 2 mouthfuls. Therefore, 1 gill equals 8 mouthfuls, which means, Jessica, that each cup has 16 mouthfuls.
Okay, thank you for explaining that.
Jasmine, what does a figure with symmetry look like?
Oh, thank you, Cece. First, let's begin with a shape. Let's look at half a circle. This image demonstrates one line of symmetry because we can draw a line of symmetry vertically, and when we compare our left and our right sides of our shape, they look identical. Now let's look at a triangle. When we draw the same line of symmetry vertically, do both sides look the same?
Yes, they do.
Awesome. This means that the triangle is symmetrical.
Thank you, Jazz.
Jasmine, maybe you can show me what a figure with no symmetry looks like.
Yes, of course. It would only make sense. Let's take a look at this figure. I will draw a horizontal line. Do both sides look like they look the same?
No, it does not.
That's right. Now let's draw another vertical line. Do you see that these sides match?
No, they do not.
Exactly. Therefore, this means that this figure is not symmetrical. Now we will look at one more shape. We will go ahead and draw a vertical line, and we can also see that both sides do not match up. We will do one last line, and once again, we see that our top and our bottom do not match up. What does this mean, Cece?
This means that it has no line of symmetry, and therefore it is not symmetrical.
Excellent job, ladies. You really know your stuff.
Claudia, how do we find the area of a circle?
Ooh, that's a really good question, Cece. There is no one-size-fits-all equation for finding area, so that's also always a very good question. I will use this figure from the homework to explain. The area of a circle is defined as pi times r squared, r being the radius always. The inner circle in this figure is 10 meters across. Therefore, the radius of the circle is 5 meters. The formula then becomes pi r squared, pi times r squared, which is 5. So does anyone know what 5 squared is?
Oh, I know. 25.
Perfect. multiply that by pi, and we find that the area of this small circle here in units of pi is 25 pi.
CC, can you explain to me how to get the measurements of each angle in the following figure?
I would be more than glad to explain to you, Jessica. Here we have our triangle labeled in with letters. The figure of the triangle has angles, and we can start by angle 1. To get angle 1, we will add up point C and point B together, which equals 100 degrees. From that, we subtract 100 from 180 and get 80 degrees. Angle 3 and angle 8 are corresponding to one another, making them both 80 degrees. Angle 2 and angle 7 are congruent, which both are 100 degrees. Angle 5 and 3 are alternate interior angles, which angle 5 is congruent to angles 1, 3, and 8, equaling 80 degrees. Angles 7 and 8 are supplementary to one another, making it equal 100 degrees. To get angle 4, we subtract 180 from point C, giving us 26 degrees. And at last, angle 6 is congruent to point C, and it adds up to 74 degrees. To the right, we have a graph which demonstrates which angles are similar and congruent to one another to help us have a better understanding.
Thank you, CC.
Hey, Claudia, is triangle QPT congruent to triangle SPT?
Yes, Jasmine, triangle QPT is congruent with triangle SPT here.
How do you know that they are congruent?
That is a great question, Cece. I know they are congruent because of the side, side, side rule of congruency. It'll come up. There we go. Which states that if the three sides of a triangle are equal to the corresponding three sides of another triangle, then the triangles are congruent, which we can see here that the two triangles share line PV and split line QS, and then QP and PS are marked with lines showing that they are similar. Therefore, the triangles are congruent.
Cece, can you explain to me what a tangent line is?
Well, of course, Jasmine. A tangent line is a line that touches the curve of a point. Above, we can see a circle that has two coordinate points being 0, 9 and -9, 0. The circle has a radius of 9, meaning it is the distance from the center of the circle to the circumference of a circle. Also, the vertical coordinate 0, 9 and the horizontal coordinates -9, 0 are parallel to each other because one x-coordinate is negative and the other x-coordinate is positive, like shown above. Let me show you what a tangent line would look like on this circle. This is where both lines of the circle curve at and forming a tangent line. Jessica, can you explain to me about similar triangles and their ratios?
Yes, CC, that is a great question. A similar triangle does not have to be the same size, but they do have to be the same shape.
So if I'm hearing correctly, you will have a dilation?
Right, Jasmine. There will be a dilation of the triangles, and the dilation means that they are the same shape, only different sizes. Here is the smaller triangle, and here is the larger triangle. As far as the ratios go, let's start by labeling the triangles. What is important is to label and name the angles that correspond together. Let me show you. Label the smaller triangle ABC. Label the larger triangle DEF. That gives me triangle ABC corresponds with DEF.
Okay, I see what you did there. Angle A of the little triangle corresponds with angle D of the larger triangle, so you say them together.
Right, Claudia, that's great. I say and label corresponding angles together. I say that angle A corresponds with angle D. angle B with angle E, and angle C with angle F. The corresponding legs of the triangle goes as follows. AB corresponds with DE, and BC corresponds with EF, and AC corresponds with DF.
Great, Jessica.
I hope you enjoyed our review over modules 1 through 5, and remember, you really can learn anything